Everybody has it.
It's the way it's
Everybody has it.
yeah.
There wasn't no homework yesterday. Yes, there was. Oh, yeah, but we got it done though, right? Yeah.
Okay. Is this exponential decay or growth or neither? So yesterday I said you look at how these are changing, right? And this is times 3 times 3 times 3. Raise your hand if you were able to at least identify that it was timesing 3 every time. Okay, I'll take it. So from there, an exponential equation is a times b to the x. Does anybody remember what the a represents? The y-intercept. And b represents the growth factor. Yeah, that's pretty much what we covered at the end of class yesterday. So to answer this question, I would say that this is an exponential growth function. And one way to justify it is because the y values multiply by 3 each time. Another way to say that in a more math term way is to say that the constant ratio equals 3. Constant ratio. And then it says to go ahead, write the function. So it's y equals, can anybody identify the y-intercept here? Yeah, it's 7. Remember, your y-intercept is always paired with a 0. 7 times 3 to the x. And if I recall yesterday, I said, man, that's easier than finding slope. That equation was easier to write than y equals mx plus b. Might not at all. Got it, Gia? You got it? Let's take a look one more time, okay? You know where I got the 7? Right there, paired with the 0. You know where I got the 3? Multiply by 3 every time. Done deal. Done deal. Number 2. The table shows the number of bacteria that grow on a sandwich. Gross. After it's left in the sun. Gross again. Write a function that models the data. Predict the number of bacteria in the 5th hour. Oh, yeah, I agree. But make sure you write an equation. I'm going to add to this to the 5th hour, then the 20th hour. Because you can just multiply with the 5th one, right? Let's talk about a 5th hour. Find the 5th, find how many will be there in the 5th hour, and then also the 20th hour. But you also have to write an equation. Gosh. Gosh. Is this 3 again?
Yes. Yeah.
I got two. Wait, yeah, three.
So it's y equals a times 3dx. But what's the y-intercept?
Oh wait, hold on. Divided by 3. Whatever.
How'd you figure that out? Oh, you just did the pattern numbers?
Yeah.
Gosh, I wish it had a 0 because the 0 is the y-intercept, right? It's like, is this missing information? How am I supposed to do it if it doesn't tell me the intercept? Gustavo, you must know. I want to know the intercept. I want to know the number that goes with 0. It didn't tell me. Did you find her? She was right in building 37, right? Did you have to knock on any doors?
We knocked on one door and somehow it was her.
Okay.
She didn't have anything.
Oh. Well, good guess then, guys. I knew you could do it.
It's hot.
You got it, Gustavo?
No. Should I go now?
Not until you figure this out. You got it?
I don't. I don't know who it is.
Oh, 8.3. How'd you come up with that, Tristan? Right. If you have to get here, you have to work backwards. The backwards of multiplication is division. Technically, it would be 25 over 3. Because if you think about it, 75 divided by 3 is 25. And then 25 divided by 3 would give you that one. So it would be y equals a crazy fraction, 25 over 3 times 3 to the x. This is all of the bell work, you guys. You just came in. Or you could just write for bell work today, Becca and Laurie, that you were returning the Chromebook card. Okay. So no. You guys know we have to find the 5th hour. Okay, so I'm going to go ahead and write that. So this is my equation. The 5th hour, the sandwich has 2,025 bacteria on it. Don't eat it. But you know who could eat it probably still is your dog. How come the dog can eat food that would make us sick? Does anybody know that?
Their immune system is stronger.
They have stronger stomachs. The acid in their stomach is stronger than ours. You know who's got crazy acid in their stomach? Vultures. You know how vultures circle and eat dead things? Dead carcasses for days? The acid in their stomach, they say, is like, it's like battery acid. It's wild. They can break down anything. They say that those things can survive like so much more than we can. I think maybe they're really old too, like almost prehistoric. Math that. Well, it's funny because that is all math that. Understanding the bacteria in the stomach, sandwich, animals, humans. All those people who study that are mathematicians. All right, one more, guys. Somehow I added to this that we have to find the 20th hour. Gosh, can anybody do this in their calculator? We did some pretty wild stuff with that credit card project. You guys are pretty good with your calculators. Do you remember the order of operations and how to use your calculators?
You might need to hurry up with that. I don't know. I found her. She ain't little. She bigger than us. Look at her. About this area. The size of my. But
Alright guys, look. So if you did it in your calculator correctly, my calculator gives me a capital E. Does your calculator tell you a capital E? Yes. You got a capital E. A capital E is how your calculator shows scientific notation. So throwback to scientific notation. So you did a two. Did you get a 2.9? Yes. You get a 2.9, and when I write it down, I don't use my calculator symbol. I instead say times 10 to the 10th because E in the calculator equals 10 to that exponent. That's scientific notation. So I went ahead and put on, I moved my decimal 10 zeros to really see it. Your calculator doesn't like to show that many zeros. That's why they do their notation. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved my decimal 10 places over, and this is the bacteria in 20 hours. Do you guys think at this point that bacteria would be visible to our eye? No. Maybe it would show like a mold or a fungus? Oh. I don't know. A sandwich doesn't usually mold in 20 hours. Fresh bread might. Like really actual fresh bread without preservatives. Mold in 24 hours. That's crazy. So 100,000 million billion. 29 billion bacteria. I bet it's smelly at least, even if you can't see it. Oh, I bet it looks slimy. So you might not see colors or anything, but I bet you can see slimy bacteria. And it's smelly. That's what I think. Mold grows in 20 hours. Like mold on like maybe a tomato, you could picture that maybe. No. What kind of food have you seen mold grow on? You can see food.
Oh, you can see it on lobsters. Like when lobsters get old, it looks green. A lot of them. Like the frozen ones.
Okay, so
Out.
you guys just have classwork today to work on this. Same page as yesterday. I'm gonna walk around and give you credit for 1 and 3. You guys are trying to finish 4 through 12. Whatever's not done in class is homework.
Let's split up the work. That's it.
Oh, I wanna write a note.
Okay. Oh, it is different from yesterday? Okay, 5:37.
She was with
5:37. Oh, 4 through 12.
Consequence minus 10 points. Oh, 0 for the day.
That's fine. That's fine.
I know.
Then I'll just do 4 through 8.
No.
I would give a referral.
I think.
Or you first,
No.
you guys
Let's
just
go.
take
I'll
your
take the phone. For the weekend.
like a weekend.
see now I'm about to take my phone for no weekend. Well, let me go ahead and get my work done so we can't say nothing about it.
Miss Baldwin.
I'll give you more.
Oh.
Yeah.
That's what I said.
Third consequence, I guess will be the.
Take the phone. Take the phone for the weekend.
They can't take your phone for more than
They can't
on a
take
third
your-
consequence. They can't take your phone. You have to give it back.
I can take your phone and deliver it to the dean to handle.
And
They
it's-
still got to give
They
it back
not
to me.
give. They not taking my job. You know, go
They
ahead.
still got to
Go
give it
ahead.
back.
Come on, Mom.
Oh, here we go. I'm at it. I'm putting it in
They
safe phone and deliver it to the dean.
still have to give it back though. That's the problem.
Yeah, but once they get it.
Now on the third one, you can call.
As a
Third one.
third consequence, how you gonna have your phone if you can't take it to the dean?
Okay, what?
Bro, what?
You're right.
Bro, what?
God.
This-
God.
she must have just want the phone gone.